Yeah.
To start this week, we've done some warm-ups. We finished the warm-up with the ToDoodle 17 from last weekend, and we just did a similar thing where whenever you moved the rings around, if you swapped two rings, one would get big by a certain amount and the other would get smaller by the same amount. And that didn't matter if you were swapping them sideways or up and down. They always had the same amount that they kind of traded back and forth. But now we're moving on. There's a nice book and it has a activity we're about to do, but you have to know the word factors. So factors are the smaller numbers that you multiply to get to another bigger number. Like 3 and 5 are factors of 15. But when I said smaller, that's a convenient way to think about them, but they really aren't, because any number has 1 in itself as factors, because 1 times any number is the same thing. So 1 times 15 is 15. So 15 is a factor of 15, even though it's just as big. So don't think that factors always have to be smaller. Everyone okay so far? So if you're thinking about factors for the first time in a long time, then a lot of people like this picture. Think about all the ways to make a rectangle with blocks and coins. So what are the factors of 12? You could make it this way, like the train or caterpillar, just a long line, 12 times 1. You could make this rectangle 6 and 2. You can make this rectangle 3 and 4. And that's all you can do. We could make a rectangle that is the same as one of these. And then just rotate it. But that's not really a different rectangle. It doesn't give us new factors. It's still 6 and 2. Everyone okay so far?
Yeah.
Okay, so just to make sure you understand factors, grab these numbers, make copies of them if you want. So there's 3 people, pick a problem and do your own problem. First, what are the factors of 5? It says there's 2 of them. There are 3 factors of 9 and 4 factors of 6. So show us you understand what factors are. Okay, we almost got it. We need a 1 down at the bottom because 1 is always a factor of everything. And we don't need to make the 3 happen twice. Ta-da! Everyone happy with our answers?
Yeah.
I'm going to make a quick comment that this is not wrong, but it is slightly slow. So it's considered polite when you list factors to list them in increasing order. Whoops, we missed our 3 over here. There was a 3 there. Just so that when you compare your work with your classmate or your teacher is grading it, that it's faster. You don't have to figure out, oh, they have the same things, but they just put it out of order. Does that make sense? So I don't think this matters for GED prep, since it's a multiple choice issue. Then if they ask you for factors, you're just going to pick the one that has the right four. But just know it's polite to put them in increasing order. Okay, but on to the fun thing. Here is the challenge. And I'm going to make a copy of it so we can mess it up and keep the original. So I'm actually on page 7 up above. Don't mess up the one that's page 6. Okay, so we have 12 envelopes. There they are. And they're labeled 1 to 12, and they have that much money in them. And your job is to grab as much money as you can. But there's a trick, a problem. Each time you claim an envelope, the tax man gets every unclaimed envelope that's a factor of yours. So I might think, ooh, I'm going to get something pretty big, like 9, but then the tax man gets 1 and 3. So I would say on this page, I'm going to get 9, but then the tax man gets 1 and 3. Make sense? So you can pick as many envelopes as you want, but you have to let the tax man have something. You can only pick an envelope if the tax man gets at least one thing, or you're arrested for avoiding taxes. And when we're done, then the tax man gets all the ones that we can't claim. So how much can we get as the most? So someone says 10, what would the tax man get? 1, 2. Let's not move the 8 quite yet. Let's finish the response to the 10. I'm going to take 8 from the quadra. Let's put it right there. Okay, so what else does the tax man get from 10? Not 3. 3 isn't a factor of 10. Yes, 5. So I'll put the 3 back. Whoops, not the basket, the 3. There we go. Okay, so the tax man has 1, 2, and 5, and we have 10. We have more than the tax man, 10 to 8, but not a lot more. Okay, it's our turn to take another envelope. Let's do one at a time. If we do 8, I saw 8 move first, then what does the tax man get? Because we have 8. 4. Okay, great. Now we can do 6. And the tax man, let's keep this over here for the tax man. So he doesn't give us money back. No refunds in this scenario. Okay, we got 6. The tax man gets 3. Can we take any more? No, none of these have factors that are still on the board. So at the end, the cleanup, the tax man gets all the unclaimed envelopes. So all this nice big amount of money the tax man got. Okay, so we are at 8 and 6 and 10, which is 18, 24 total. So not bad, but I bet we could do better. So now I'm going to go back and duplicate this again. Oh, no. Duplicate. Okay. So now I'm going to erase this one and put page 8, please, on the one that I want you on. So let's do exactly the same thing again. But our job is to beat 24. Can we get more than 24? 12. Okay, somebody be the tax man. 6, 2, 3, yeah, 1, 4, So all of those are factors of 12. We can do 10, then the tax man gets 5, that's fine. None of these other numbers have factors still on the board. So cleanup time, the tax man gets all of those. How much did we get this time? 22. So we did better the other time. Ready to try it a third time? So I will duplicate that, move it to the right spot. But page 9. You go to page 9. I'm going to quickly erase that. Yeah. Okay, go ahead again. 11 is good. What does the tax man get? Only 1, right? Nothing else is a factor of 11. But we got 2 things. Do you want to do not keep 11? 11 was a great first move. Do you want to do 9 or 12 first? I saw 2 suggestions. 9, okay. If we do 9, what does the tax man get? Only 3. Okay, I'm going to scoot these in a little. So the tax man currently has 1 and 3, and all the rest are still valid in the middle. Well, that means the tax man gets 2, yes, and 4 and 6. We can do 10. The tax man gets 5, 7 and 8 are stuck in the middle, and the tax man gets those. Okay, we've done substantially better. 9 and 11 is 20, 30, 42. So I'm going to put try 3. This one was try number 2. Just so if you're looking at this later, our record is complete. Okay. So we're getting better at this. And I'm not going to tell you if 42 is the best possible thing. You can play around with it more if you want. Maybe it's a good brain teaser to do at home with friends or family. But how big can you get for your share of them? Now, that book that I talked about, the Building Thinking Classrooms, has a lot of advice on what to do in a math class. And we're doing a lot of the things from that book, which hopefully is why you like our math class. But we're ignoring some of the advice. For example, that book says, when you give instructions about something, the teacher should do it out loud, not in writing. But everything here, all the instructions are always in writing. So that later on, when you can look at your copy of things, then you can review after class and see if it makes sense to you, which you couldn't do if there was nothing written there. We also work together as a class, as it's kind of a small class. The book says, for people older than first grade, 3 is the best group size, and science has sort of proved that. But we have groups that are bigger instead of using breakout rooms, because in a breakout room, then we can't all cooperate. We can only hear each other. It's not like a physical room where you can kind of pay attention to the people on the next table and get up and go over and say, how did you do this one and stuff. It's much easier for groups to cross-pollinate in real life than it is on Zoom. And the book recommends that people stand up at whiteboards rather than using Zoom in a Jamboard. But again, this is what we have. So if you want a picture, then I'm going to share some pictures. So here are some pictures of what research says a great math classroom might look like. So whiteboard is hung up, some of them down low if students are short, some tables to work at when you need to, but a lot of standing up and working in groups. And then here's some cute pictures of elementary school students that are actually doing it that way. So not that all the schools in our neighborhood school district are actually learning on what's happening, but it's interesting to see that the science of what helps people learn math has gotten settled and is ahead of how math is actually taught in schools a lot. Okay, I'm going to stop recording. We can either discuss this kind of thing or whatever you want.